Okay, so we'll start with the first question from your toy sheet there, which is saying, determine the number of significant figures in each of the following values. Okay, so like I made mention, what's important is you knowing the principles. Once you know the principles, then it will be easy for you to answer this question. Some of these things you already know, but let's remind each other of some of the things that you've forgotten. Okay, so we are talking about the rules of getting the number of significant figures in a figure. Okay, so what are the rules that govern the number of significant figures? Okay, so let's look at the rules that govern the number of significant figures. Then you should be able to answer the questions that have been given there. Okay, so there are rules that governs the number of significant figures. The first one that you must know is that all non-zero numbers are significant figures, isn't it? So we are saying all non-zero numbers are significant figures. Okay. Apart from that, the other rule that govern the number of significant figure is that if you're having a zero, okay, a zero in between non-zero numbers, so a zero in between non-zero numbers, that zero is going to be significant, isn't it? So it's going to be a significant figure. So if you're having a zero in between non-zero numbers, then that number is going to be, that zero is going to be a significant figure. So let's say we're having 5,001. Okay, so you notice that these two zeros here are in between two non-zero numbers, isn't it? So these zeros in this case are going to be significant. Okay, so that's what we are having. Okay, the other thing that you need to know, the other rule that governs the number of significant figures is what we call the leading zeros. Okay, so what are leading zeros? Anyone to help us understand what leading zeros are? So what are leading zeros? Okay, go ahead. There's someone who wants to give us an answer. What are leading zeros? Okay, so for the sake of time, leading zeros are zeros that are going to appear before a non-zero number. Okay, so it doesn't matter whether there's a decimal point or there's no decimal point, as long as the zero is in front of non-zero numbers, then it's going to be called a leading zeros. Okay, so all leading zeros are not significant. Okay, so all leading zeros are not significant. So if you're, let's say you're having a number 003, okay, so you notice that these zeros are in front of a non-zero number, isn't it? So in this case, these zeros are not going to be significant, right? So they are not significant. Okay, now let's bring a point. Okay, so let's say you're having 0.03. So these zeros are still in front of a non-zero number. So in this case, these zeros are not going to be significant as well. Okay, so that tells you that any zero in front of a non-zero number, as long as there's no other non-zero number, then those zeros are going to be are not going to be significant, isn't it? So like we are giving examples here. So you notice that this is 3. It's a non-zero number, right? Then you're having these two zeros in front of 3, right? So these are not going to be significant. Whether there's a decimal point or not, they are not going to be significant figures. I hope people are clear there. Okay, so that's about leading zeros. Okay, there's also the other type of zeros that you need to know, and we call them the trading zeros, isn't it? Okay, so we have what we call the trading zeros. Okay, so trading zeros are zeros that are going to appear after a non-zero number, isn't it? Okay, those are going to be called the trading zeros. So zeros that appear after a non-zero number, they're going to be called trading zeros. Now, there's a thing when it comes to trading zeros. Okay, so depending on the situation, where if you're having a decimal point and then you are trading zeros, then those zeros are going to be significant. Okay, so we are saying trading zeros are only going to be significant if there is a decimal point, isn't it? A decimal point. Okay, so what I'm saying is this. So let's say if you're having a trading zeros, let's say we have a 300 like this. So these are trading zeros, right? So you notice that they are appearing after a non-zero number, right? So these are trading zeros. So in this case, we don't have any decimal point. So trading zeros, when there's no decimal point, these are not significant. So they are not significant in this case. They are not significant figures, okay? But if you are having a decimal point, let's say we have 3.00. So you notice that, yes, they are trading zeros. Yes, they are appearing after a non-zero number, but there's a decimal point. So that decimal point makes these zeros to be significant figures. So in this case, we are going to have 3 significant figures in that number. I hope people are clear on all the rules that govern the number of significant figures. Do we have a question so that we answer these questions that we are having on the tutorial sheet? So with this explanation I've given, this should be easy to answer, isn't it? So let's answer. Let's start with the first one. How many significant figures are we having here? Anyone? Feel free to participate. Let's interact. Anyone, according to what we've discussed?
We have 3 significant figures.
Good. So we are having 3 significant figures because we are saying this is a 0 in between 2 non-zero numbers, isn't it? So in that case, that 0 is going to be significant. So in this case, we are having 3 significant figures. What of the second one? How many significant figures are we having there?
1.
Let's be fast.
1.
1. Okay, so there's one is saying 1. The number is 3.00. So we have a suggestion. One is saying it's one significant figure. Anyone else wants to give it a try?
3.
3.
Okay, so everyone is saying 3 significant figures. Okay, so now let's go back to this rule here. We are saying trading zeros, isn't it? So we've made mention that we have trading zeros that will have a decimal point and trading zeros that will not have a decimal point. And I've made mention that if there's no decimal point like this here, 300, we have these trading zeros and there's no decimal point. In this case, these zeros are not going to be significant. So we are going to have one significant figure, isn't it? That's what we made mention, right? But if we are having a decimal point, in this case, there's a decimal point here, okay? On this number, there's a decimal point, okay? Then we have these trading zeros. In this case, these trading zeros are going to be significant. So here we are going to have 3 significant figures. Okay, thank you so much. Okay, let's go to part C. Part C, we're having 3.20. How many significant figures are we having there?
3.
So it's important. Good. 3 significant figures. So it's very important to understand these principles. Even as we are going to other complex chemistry, you should be able to know these principles so that even as you are getting your final answer, you should be able to know the significant figure your answer should be. Okay, let's go to the next one. 0.25. How many significant figures are we having here?
2.
2 significant figures, isn't it? So we've talked about leading zeros. So we are saying leading zeros doesn't matter whether there's a decimal point or there's no decimal point. As long as it's a leading zero, it's not going to be significant. So in this case, this 0 is not significant. Okay, so we have 2 significant figures. Okay, what of E? What of part E? How many significant figures are we?
3.
3 significant figures, isn't it? So we have 3 significant figures as well. Okay, so we have these 2 zeros, which are leading zeros. They are appearing in front of a non-zero number. They are not going to be significant Okay, despite us having a decimal point there, but these zeros are leading zeros. Leading zeros are never significant, isn't it? So now let's go to part F. So part F is a bit interesting. So we have 0.002910. How many significant figures are we having here?
4.
3.
3.
3.
So there are others who are saying there are 3 significant figures. And then there are others who are saying there are 4 significant figures. Okay. So now let's look at the type of zeros that we're having. Okay. So definitely we're having these zeros which are leading zeros, right? They are not significant. We do agree that these zeros are not significant, isn't it? Now we have this type of zero, which is a trading zero, right? Now, the
Yes.
question you need to ask yourself, is it appearing after a decimal point or before a decimal point? Because we are saying if you're having a trading zero and it's after a decimal point, then that zero is going to be significant. That's what we made mention, isn't it? So in this case, is this zero significant or not?
Yes.
It is
It
significant
is.
because it is appearing after a decimal point, right? So in this case, we are going to have 4 significant
4
figures.
significant. Yeah.
Okay. I hope people are clear there. Okay. So we go to part G. Part G is the first rule that we made mention. All non-zero numbers are significant. In this case, we are going to have 4 significant figures, isn't it? So let's go to part H. Okay, so how many significant figures are we having there? Let's be fast so that we move on.
5.
5.
Good. So this zero is significant because
Yes.
it's let me just share my screen. Yeah, so I hope people are still able to see what's on my screen now. I've shared my screen.
Yes, we can see.
Okay, so here we are saying this zero is going to be significant because it's in between non-zero numbers, isn't it? Let's finish with the last one, which is G.
5.
So you're having 0. Okay, so here we're having 4 significant figures, isn't it?
Yes. Yeah.
Okay, so let's go to this one. So someone has already given us an answer. So they're saying it's 5 significant figures, which is true. The reason is that this zero is not going to be significant. It's a leading zero. Okay.
Yes.
This zero is going to be significant. It is appearing after a decimal point. It is in between non-zero numbers. So in this case, it's going to be significant, including these 2 other zeros, which are appearing after a decimal point. So they are also going to be significant, right? They are trading zeros appearing after a decimal point. So in this case, we're going to have 5 significant figures. Hope people are clear there. Okay, so let's go to the next set of questions. Okay, so the question is saying write each value with 3 significant figures. Use scientific notation if necessary. Okay, so we are still applying the same use of significant figures, but we need to have 3 significant figures, and we are allowed to use scientific notation if necessary, right? So let's start with the first one there. Okay, so how many significant figures are we having in this number? 34, 5.
3.
How many significant figures?
3.
How many
5.
significant figures?
It's 5. 3.
Okay, so there are others who are saying 5, there are others who are saying 3. So let's go back.
It's
Okay,
3.
so remember I've said you need to know the principles. So the principles here, the type of zeros that we are having are trading zeros. And we've agreed that if we are trading zeros that are appearing and there's no decimal point, then those zeros are not going to be significant. So trading zeros are only significant if we are having a decimal point. So in this case, these trading zeros here, there's no decimal point anyway, right? So they are not significant in this case. So we have three significant figures already, right? So we can leave it the way it is. It's already having three significant figures. Or we can also use a scientific notation, right? To make things okay. Okay, so we can just move how many steps? Okay, so we are moving to the right. Remember, when we are moving to the right, we are moving to the left. From your right to your left, we are coming up with the scientific notation. We know that we're going to get a positive number, isn't it? So we have moved our decimal point from this position. So we have 1, 2, 3, 4. It has moved 4 places, isn't it? So we are going to have 3.45. Now, when you introduce a point, you don't have to put those zeros. If you put these two zeros, it means that they are going to be significant, and our, our this would destroy the thing the thing we are looking for, isn't it? Which is three significant thing, right? So we don't want to put those zeros. Okay. So what we are going to do, we're going to introduce scientific notation, isn't it? So we are saying we moved 4 terms, and if we are moving from your right to your left, we are saying we are getting a positive, isn't it? So in this case, we are going to have to the power 4. Okay. So this is three significant figures as well. Okay. So two answers. So you can either have the same one or this one in scientific notation. You're still going to have three significant figures. Okay. So let's move to the second one. 24. How many significant figures are there?
Two.
Two.
Two significant figures. And we need three significant figures. What can we do? What can we do?
We put a zero, a comma.
Okay, so we can put 0.0. We know that this zero is still going to be 24, but when we put a point here, it means that we're getting the next zero to be significant, isn't it? So in this case, you're going to have three significant figures. So that is our answer that you're going to get, right? Let's go to the next one. This one here. 3. Let me just share. Okay. I hope people are able to see my screen now.
Yes, we can.
Yes. Yeah. So I was saying we are having, okay. So I was saying we are having this number here. Let me just so that you have a clear view. So you're having this number here, 0.0
Zero,
345.
5.
Okay.
Mm-hmm.
Okay. So now we are saying already we are having three significant figures, isn't it? So we can leave it the way it is. It's okay. Still the answer, isn't it? But we can also use scientific notation by moving the decimal place here. So from this position, we can move it 2 times. 1, 2, isn't it? So if we move it 2 times, it means that our scientific notation is going to look like this. So having 3 point, our decimal point is now here, isn't it?
Yes,
3.45 then times 10.
10
So the
to the power
thing
negative.
I was, yeah, so the thing I was mentioning of moving from the left to the right. So whenever you are moving from your left to your right,
It's
you
negative.
get a negative, isn't it?
Yes.
And then when you are moving from your right to your left,
To
you
your
get
left,
a
it's
positive. So
positive.
here we've moved 2 steps, and we are moving towards the right, isn't it? So we are getting a negative 2 here. That's what we have. Okay. So let's go to the next one here. Okay, D. So we're having 0.012. Okay. So how many significant figures are we having here?
2.
We're having 2, isn't it? These are
Yes.
leading zeros. So I encourage everyone to understand these principles. Once you know this, it will be easy for you. Okay, so we are going to upload this video on YouTube and we'll share with you. So just make sure you get familiar with those principles. Once you know,
Okay.
it will be easy for you, right? Okay,
Yes.
so we have these zeros which are in front of non-zero numbers, which are we call leading zeros, and they are never significant. So in this case, we're having two significant figures, right?
Yes.
Okay, so what can we do to make this to have this as three significant figures? Anyone? Anyone to give it a try? Okay,
Can
so
just
we can
add
move.
a zero at the end.
Good. Yeah, so we can just introduce a zero there, isn't it? So this zero is
Yes.
going to be significant. It's appearing, it's a leading zero, it's a trading zero appearing after decimal point. So it's going to be significant. It's not going to affect our number, still 0.012, isn't it? But if you add a zero there, that zero is going to be significant, right? So this is going to be our answer. For scientific notation, we can move our decimal place, isn't it? So we are
Yes.
moving two steps as well. So we're going to get 1.20 times 10 to the power negative 2. That's what we have. Okay. Let's go to this one now. Okay. So we're having 612.8. Okay. So now we want to have three significant figures. So what should we do in that case?
Round.
What answer are we going to have?
Yeah, moving from the
It's 1 3.
left to the right.
Good. 612, right? So you notice that you're having an 8 there. Okay. So whenever you're
Yes.
having a 5 going up, we are supposed to move to get 1 and add it to a 2, isn't it? Okay.
So we round
Then we're
off.
going to have, yeah. So we're going to have 613 as our final answer there. Okay. So that's three
Yes.
significant figures, isn't it? What of the
Mm-hmm.
next one? Same principle. We are just going to drop a 2 there, isn't it? It's less than 5, so we're going to drop a 2. So we end up having 198.2 as our final answer, isn't it?
Yes.
Okay. All right. Okay, so let's go to the next one, which is 0.14928, right? How many significant figures are we having here?
5.
5.
5.
Okay, good. Okay, so three significant figures. What should we do? So three significant figures is going to end there, isn't it? So we look the
Yes.
number next to 9, which is 2. 2 is less than 5. Whenever you're having a number less than 5, you are supposed to drop whatever you have, isn't it? So our final answer is going to be 0.149, like that, right? Okay.
Yes.
Now we have a
Mhm.
300 there. A 300. We want to have three significant figures. So what should we do in that case? What should we do in that case? So we can use scientific notation, isn't it?
Yes.
So if we use scientific notation, it means that you're going to move 1, 2, isn't it?
2.
2 steps. So
Yes.
you're going to have 3 points. Now, I'm not going to get rid of this 0. Okay,
Yeah,
so
don't get rid.
the thing is that us, we want to have three significant figures, isn't it? So I want to maintain those zeros so that I get my three significant figure. Remember, the scientific notation does not affect the number of significant figures. So if I maintain my zeros there, I'm going to have three significant figures, isn't it? Here, there are no
Yes.
Okay.
significant figures because they are trading zeros without the decimal point. But once we introduce a decimal point there, then they are going to be significant. Then we have to the power 2 there. That's what we have, isn't it? So we are
Yes.
done for
Yeah.
this session. Okay. So these, I
Okay.
hope people are familiar with the rules that govern the number of significant figures. Okay. So now we are still discussing the number of significant figures, but let's move a bit. Now we use them in operations. Okay, so this is something that we are going to be doing in physics, in chemistry, in math. This is what you are going to be doing. Operations. You can't run away from operations as long as you are doing those subjects, isn't it? Okay. So now
Mm.
let's discuss operations. We know that we have 4 operations, right? Okay. So we have what we call divisions. We have division. We have multiplication. Then we're going to have addition. Then we have subtraction, right? These are the 4 operations that we have, right? Unless there's something else that I don't know, but these are the operations that we have, right? Okay. So now
Yes.
for these operations, we can apply the rules of significant figures when we are using these operations. Okay. So here is the principle. Okay. So when you are adding or subtracting, your final answer should be left according to the least decimal place. Okay. According to the least decimal place. Okay. So if you're adding 2 numbers, your final answer should be left according to the one having the least decimal place. Okay. So
Okay.
let's use the first one as an example. Okay. So you're having 0.23 plus 4.2. So
2.
the question you need to ask yourself is, how many decimal places are we having here? So definitely, I assume everyone knows how to count here. So you should be
Yes.
able to count, right? So here, how many
Yes.
decimal places are we having here?
2.
2.
2, right? What of here? How many decimal places are we having?
1.
1.
1. Okay,
One.
so now the principle is simple. Leave your answer according to the least decimal place. Okay, so it means that your final answer should have 1 decimal place,
Decimal
isn't it?
place.
1 is smaller
Yes.
than 2, right? So your final
Yes.
answer should have 1 decimal place. So someone to add for us and give us the answer, the whole answer when you add the 2. So add 0.2,
12,4.
4,
4.
4. Just give me the entire answer, the whole answer as it's
3.
appearing before you give me comma 4 what?
3.
3.
Cool. So that's what we are having, right? But we are saying we need to apply the rules of significant figures. And we are saying when we are dealing with operations, whenever we are adding or subtracting, we give our answer according to the one with the least decimal place. Okay, so this is
Yes.
supposed to have 1 decimal place. So that's where the 4.4 is coming from. Okay, I hope people are clear there. So same applies when you're subtracting. Okay, so the second one here, let's do the second one. So we're having 13 minus 1.03. So 13, how many decimal places are there in 13?
0.
0, right? So it means that our final answer should not have any decimal place, isn't it? So let's add the 2.
Yes.
What are we getting? When we add the 2, what are we getting?
11.97.
11.97. Okay. So what would be our final answer in this case?
12.
4. Good. Okay. So you see a 9 here. Whenever we're having a number greater than 5, we get a 1 and add to the next one, isn't it? Which is
Yes.
going to give us 4 there. Okay. So that's our final answer. I hope people are clear. Okay.
Yes.
So that's
Very clear.
subtraction and addition. So you give your answer according to the least decimal place. Okay. Now for division and multiplication, you are going to be leaving your answer according to the one having the least significant figures. Okay. So you need to check the number that you are dividing or multiplying. Which one is having the least significant figures? So meaning your final answer should do follow the one with the least significant figures, right? That's what we have. Okay. So let's use this one here as an example. So having 34 multiplied by 0.12. Okay, so what are we getting there? when you multiply? Give me the whole answer. What's the answer there when you multiply?
4.08.
4.08. Okay. So now, if you check this 34, how many significant figures is it having?
2.
2. What of this one?
2.
So it means that our answer should have 2 significant figures, isn't it? But here, how many significant figures are we having?
3.
3.
Okay. So what would be our final answer in this case?
4.1.
Okay. Good. So 4.1. That's the final answer that you are going to get. All right. Okay. So let's divide the next one. So we're having 68 point. Okay. So let me get them different significant figures. Okay. So let me get which one here? Okay. So let me get some having two significant figures. Okay. Which one can we use here? Okay, let's try the last one. So we're having 592, okay, times 10
Yes.
to the power 3. Then we are dividing with 0.68. Okay, so let's do that. When we divide, what are we getting there? Give me the full answer. When you divide, what are we getting? What are we getting there?
2.
Okay.
2. It's 9. It's not 2. It's 9426.
9426.
0.751592.
0.75
1592.
92. Okay, so this is the number we're getting. So we are saying when we are dividing or multiplying, we need to get the final answer to the one with the least significant figures, isn't it? So if you check here, how many significant figures are we having in this number? 3, right?
3.
Same with the other one. So 3, and we are
3.
dividing. So it means that our final answer should have 3 significant figures, right? Okay.
Yes.
So what would be the final answer there? 943, right? Yeah. Point. Okay. So 0. You put a 0 here, right? Okay.
Yes.
Like that, right? Now we can also use scientific notation. Right? We are moving a point 1, 2, 3, isn't it? So we can have 9,
9.
4, 2
Same.
times 10 to the
Same.
power 3.
It's 9
isn't it?
points.
Yes, 9.42 times 10 to the power 3. Like that, isn't
Say, I
it?
have a question.
Yes, you can
Say,
ask.
can you please repeat?
3 significant figures, isn't it? And the one down also is also having 3 significant figures, right? Okay, so after dividing, we are getting this number here. Okay, so now what we want is to have the correct number of significant figures, which is 3 significant figures according to the principle that we've agreed here, saying when dealing with these two operations, which is division and multiplication, we are going to be leaving our answer according to the one with the least decimal, with the least significant figures. And we notice that the one with the least significant figures here is 3, right? So we need to have our final answer to 3 significant figures. Now, after calculating, we are getting this number. Okay, so we need to make sure that we have 3 significant figures. So I've answered 2 ways in which we are going to have 3 significant figures. The first one, I checked, I counted 1, 2, 3, isn't it? So I want to end here where there is a 2, right? and I check the next number, which is 0, right? Which is 6, right? 6 is above 5. So what I'm going to do, I'm going to get a 1 and add it to a 2 there. That's where the 3 is going to come from. Now we can't just drop the 6 without adding anything. Then it will affect the whole number, isn't it? So in this case, you have to put a 0 there so that you maintain the number that you're having. I hope people are clear there.
But sir, doesn't that make them 4 significant?
So now you're saying you're having four significant figures. No, we are having three significant figures because we are saying this zero now is a trading zero. And they are not, we are not having any decimal point in this number. So it's not significant. So we still maintain the 3 significant figure and still maintain the number that we wanted.
Okay.
Imagine if we just leave it, it will be 900, right? But if we maintain the 0, it will be 9,000, the number that we wanted, right? So we
Yes.
still want to have thousands in that case. We don't want to have 100.
Okay.
Yeah. Or we can use scientific notation where I was moving the decimal point from here to here, isn't it? Okay, so whenever
Yes.
you're moving the decimal point, you just have to make sure that you only have one number in front, isn't it? That's why we've moved from this position to here. Okay, so that we only have a 9 in front. So we get this number. Now we are not going to put a 0 there. If we put a 0, it means that we're going to have, okay, so this is 3, right? Oh, is it 3? Yes. Is it 3? It's 3, right? It's supposed to be 3 there, right? Okay, so we are not putting a 0 in that. If we put a 0 there, it means that we are going to have 4 significant figures. So we are just going to leave the 0, the other 0. Okay. I hope I haven't confused people here. I hope we are together.
Yes.
Okay. So let's move. Okay. So now I hope people are clear on the operations, how you're supposed to give your final answer whenever you are adding or subtracting, and when you are dividing and multiplying. I hope it's clear. Okay. So there are some more questions. Can you mute your mic unless there's a comment you want to make? That's when you unmute yourself. We are getting feedback. So there are some other questions here which have not been solved. But notice that this tutorial sheet, I'll show you how you can find this tutorial sheet on the website. So you just go on the website. This tutorial sheet was just repeated. It was for last semester. It was repeated. So you can just go there, you watch the full video for the other solutions if you want. Okay. So that's what we have. So let's move to the other things today, which is the last thing I want us to discuss. Okay. So before I even need the question, there's these 2 things I want us to understand, which is precision and accuracy. Okay. And the other question that you can be asked is to define, to differentiate. You need to know what a quantitative measurement is and a qualitative measurement. So before we even go to this question, let's discuss those 2 things. What is a qualitative measurement and what is a quantitative measurement?
A quantitative is numerical and the qualitative is non-numerical.
Okay, good. Okay. Qualitative and quantitative, isn't it? So for quantitative, we are saying numerical, isn't it? So you have to use numbers. Okay. So for example, you get your your weight is 51 kg. Okay. So that's a numerical we are using, isn't it? So 51 kg, that's a number. Okay. So that's a quantitative measurement. For a qualitative measurement, you are not going to be using numericals, isn't it? So there are no numericals involved. Okay. So for example, you are performing a titration experiment. Remember where you have to put when you're performing a titration, you put an indicator, right? then at some point you'll be observing the color change, isn't it? So let's say you say, okay, color change 10 purple, okay, or maybe you are doing a protein test, then you say no, you are supposed to get a whatever orange, whatever color you get when you're doing that experiment in biology, whatever. Okay, so you are just observing. Or let's say, we're going to get, if you're doing an experiment for ammonia, we are supposed to get a pungent smell if ammonia is present. So we are not involving numbers, isn't it? That is going to be a qualitative measurement. You should be able to differentiate between the two. I should be able to give examples like the ones I've given. I hope people are clear.
Yes.
Yes.
Are we okay?
Yes,
So
we're
you should be able to
following.
do that. Yeah. Okay. So now let's go to the main topic of discussion, which is precision and accuracy. You really need to understand this. You are going to be asked. Okay. So precision and the accuracy. Okay. So what is precision and what is accuracy? Should be able to differentiate these two.
Isn't precision how close values are to one another? Then accuracy is how close it is to the actual or
Good. Okay, so that's it's simple as such, isn't it? So precision, you are looking at a list of measurements that you are doing. For example, you're doing a titration, then you get these measurements. Let's say 25.01, you get 25.02, you get 25.03. Okay, so these are the measurements that you are getting in a titration reaction. Now, for precision, you want to see how close these measurements that you are getting are to each other, isn't it? That is precision. If they are very close to each other, then you are going to say you are precise, isn't it? Okay, so you should be able to understand precision. I hope people are clear on precision. So how close measurements are to each other is what we call precision. Okay, then for accuracy, we are talking about, let's say you have a specific measurement, a true value that you've been given. Okay, so let's say we are given 8.31. Okay, then we are doing a measurement. Let's say we are measuring volumes. We are performing a titration. We're getting different volume. Now we want to compare that volume with the number that we've been given with the true value. So accuracy is how close your value is to the true value, isn't it? So in precision, we are looking at different measurements, how close different measurements are to each other. In accuracy, you are simply comparing the value that you've gotten with the true value that you've been given, isn't it? That is accuracy, isn't it? So if the number that you've been given is closer to what you are getting in an experiment, then you are accurate, isn't it? And then if the different trials that you've done are having measurements that are closer to each other, then you can say you are precise. Okay, I hope people are clear there. So once you understand that, then everything is easy for you. You should be able to answer these questions that are here. Okay. Okay, so let's answer the question. I'm assuming people understand what precision is and what accuracy is by now. Okay. So the question is, the density of a copper sample was determined by three different students shown below. So these are the students that we have in here. Their names are there. Don't mind the names. Even if you don't know the names, it's okay. What's important are the numbers. Okay. So this is Elato, this is Musonda, Tinashe. Okay. And we've been given the measurements that we are getting, right? Okay. So each performed the measurement 3 times and is reported below, and we've been given the measurements that we are getting there. So the accepted value for the density of copper is 8.92. So this is the accepted value, the value that I was talking about, the true value, the one that will be comparing. That's the accepted value, right? Okay, so now let's answer our question. Let's start with the first part. Part A, determine if each student's data is accurate, precise, neither or both. So for each, let's start with Lilato. So let's check if Lilato is accurate. Then we'll check if it's precise or is neither or is both. Okay. So let's look at the measurements that we've been given for the laptop. Okay, so we're having 8.94. Okay, so we're having 8.89. Then we are having 8.91. Okay, so now the question is the laptop accurate or not? Is it precise? Is it accurate? Is it neither? Is it both? Then I want to give it a try on the first question there. And you explain why you think it's like that. Okay. So is it accurate? Is the laptop accurate?
No, it's accurate.
Why?
It's precise.
Okay. What? Okay. So you're saying it's not accurate, but it's precise.
Mm.
So why are you saying it's not accurate? So there should be a reason why you're saying it's not accurate. There should be a reason for anything. Even you doing something there should be a reason, right?
Yeah,
We always
it's
have a
accurate.
reason for
It's
something.
accurate. It's
But
accurate.
Both.
I think it's accurate because
Yeah,
there's
it's
what-
accurate.
8.91. There's
It's both.
8.91. It's close to 8.92, the accepted
Yeah.
value. Because
Okay.
accurate doesn't mean that it's exact.
Yeah.
It means that it's close to it.
Mm.
Okay.
So
So
it's
if you look at the
accurate. Yeah.
measurements, so if you look at the measurement that this laptop was getting, they are very closer to the value that we've been given, right?
Mm. Mm.
So
Accurate.
we can conclude that the laptop was accurate in this case,
Accurate.
isn't it? So look at the values
Yeah.
that he was getting. So if you compare this value to the true value, it's very close, isn't it? Even this one to the true value is also close. And then also that one to the true values are also close. What of precision? Is it precise or not?
No.
Is it precise? So precision, we are looking at how close the measurements are to each other. So now let's look at these measurements. Are they close to each other?
Not
No.
really. No.
Yes.
9,
Okay,
4,
so
8, 9, and 9. Yeah, they're close to each
They
other.
are close.
They are close.
They're
they are
close.
close
to
to
each
each other,
other.
isn't it? So this
I
Mm.
thought
8.89
it's
is
close.
it's closer to
They are not close because
8.9.
there's 8.89 and then we have 8.94 and then we have 8.91. It's not close, guys. It's not. Especially
They- they-
8.89 and
They are
8.94.
close.
The
They
difference
They
are-
are
is
close
fine.
if you round off. If you round off to the nearest tenth, it's close.
Yes. Okay.
Yeah,
okay.
if we
So let's
round,
assume we are rounding off to the nearest 10. Yes. So we are going to be getting these numbers to be closer to each other, isn't it? So we
Yes.
can
Yes.
conclude that the laptop in that case is both precise
Accurate
and
and
accurate,
precise.
isn't it? Okay. Can you mute your mic unless there's something you want? There's a contribution. That's when you unmute yourself so that we are not getting a lot of feedback. Okay. So let's go to Musonda. Let's check if Musonda is precise or accurate. Okay. So we're having these values 8.32. Then we have 8.31. Then we have 8.34. Okay. So
It's
is he
precise.
okay?
It's
He's
precise.
precise, isn't it? Good.
Mm.
He's precise, but accurate. Is he accurate?
No,
No.
not
No.
even,
No.
not even
Yes.
half.
No.
Yeah. So
Not
it's not
even.
accurate, right? Good. So it's just precise, but not accurate in this case, isn't it?
Yeah.
Okay. So
Yes.
let's look at the last
say,
person, Tinashe.
say,
Okay. So we're having 8.64. Then we have 9.71. Then we are having 9.10. Is it accurate?
No.
No,
Yes,
no.
good.
Neither.
So if we compare these numbers, they are not closer to the given the value there, isn't it? So
They're
it's
even
Yes.
neither
above.
accurate or precise, isn't it? So
Yeah.
even the closeness of the number, they are not closer to
It's
each other.
They are not
neither
precise.
neither
Yes. So it's
neither
neither
precise.
precise nor accurate, isn't it?
Accurate. Yes.
Okay, so that's what we have. So we are done with the first part. The second part is what is the average density based on Sonda data? So average, we simply get the data that we've been given from Sonda layer, which is 8.32. So we're going to summate whatever data we've been given, since we're getting the average, isn't it? So we get 8.32 plus 8.31 plus
8.31,
8.34.
8.34,
Then we are going to divide with the number of measurements that we are having, which are 3, isn't
which
it?
is 3.
So,
Yes.
so give me the final answer to these significant figures. I'm saying that because by now,
8.32.
okay, so 80.32. Okay, that's the average, isn't it? Okay, then the last one is saying what is the average density based on Dirato's data. So this one here, we do the same thing, isn't it? So someone to give me the final answer there, the average. Okay, so you're simply adding 8.64 plus
No, relative.
9.7. Oh, sorry. So the first one, isn't it? So we have 8.94 plus 8.89 plus 8.91. Then you divide by 3. What's the average number? Three significant figures.
8.91.
8.91. Okay. So I hope people are clear on precision and accuracy.
Yes.
Okay. So let's finish up the tutorial sheet to the last question, question number 5. Okay. So the first question, A, say a patient needs to increase their calcium supplement by 25% a week. Okay. So I said we need to increase the calcium supplement by 25%. Okay. So we need calcium in the body. Calcium is important for muscle contraction. We need calcium, isn't it? Okay. So we want to increase the calcium supplement in the body. So we want to increase it by 25%. Okay. So if they are currently taking 300 milligram supplement, so we're taking 300 milligram supplement, how much more will they need to take? So we want to increase it by 25%. Currently we are taking 300, right?
300 each.
We want to increase it by 25%. Okay. So what do we do in this case? So the first thing that you want to know is the 25% of the 300, so that you add it to the 300, isn't it?
Yes. Yes.
So how do you get 25% of 300?
25 by 300. 25
Okay,
of
so we
100.
know that a percentage is always out of 100, right? So we're going to get a 25
Yes.
by 100, then we multiply with a 300, isn't it? So what are we getting in that case? 75, isn't it?
75.
Is it? Good. Okay, so what we are going to do, we are going to say this 75 milligram, we add it to the 300 so that um, we know how much they will need to take for us to increase by 25%, isn't it? So what will be the answer there? Should be 375 milligrams.
375.
Okay, so we are done
Really
with the first question.
close.
Straightforward there, right? Should be able to answer such questions in a test or an exam. Okay, so now we go to the next one,
To
which is part
decrease.
B. Okay, so part B saying a patient needs a 20% decrease in their medication dose from 125 milligram. Okay, so I don't know if there are people who are doing pharmacy. Here, if there are people who are doing pharmacy, this is going to be important. This is what you're going to be doing. Okay, so we notice that this is a patient. Okay, we need to increase the dosing by
Decrease.
20%. Or
Decrease.
we need to decrease, sorry. Okay, so we are decreasing by 20%. Currently, we are giving this patient 125 milligram. Okay, so we're giving this patient 125 milligram and we want to
So
decrease by
sorry, say
20%.
Sorry, sir, to interrupt.
Yeah.
Yeah, on that first question, the question says how much more will they need to take? Do we have to add the 75 to the 375 or they just need the 75?
Yeah,
So,
good question.
how much more? Okay, so how much more?
Yes.
Yeah, you need to
So,
add, yeah.
so currently we are taking 300, right? So it means that
Yes.
you need to how much more? Okay, so the English here. So how much more are you supposed to take? So is it at
It's
75?
75.
75,
It
right?
should be 75.
Mm.
Good. Okay, so thank you for that correction. So the English here should be 75 milligrams, isn't it? That's how much more they should take for them to get the 375, right? Milligram. Okay, so good. Thank you so much, sir, for that. Really appreciate you. Okay, so how much more you should take 75 milligram for the dose for the supplement to increase by 25%, isn't it? So that's what we have there. So that's what we have. Okay. Then the second one, we are decreasing. Okay. Okay, so we are decreasing by 20%. So we need to get the 20% of the dose that we're having, right? So we get 20% of the dose, okay, which is 125, right? Milligram. Okay. So what would be the 20%?
25.
25.
It's what?
25.
25.
25 milligrams, isn't it? So that's the percentage that you need. That's the amount that we need to decrease. Okay. So now the question. Let's be careful now. The question is saying what will be his dose
After
after
the
the
decrease.
decrease, isn't it? So now here we need to subtract now, isn't it? So we want to know what will be the
Yes.
dose after decreasing, isn't it? So we get
Yes.
125 milligrams minus the 25, which is the 20%, isn't it? Okay.
Mm-hmm.
So what do we get? We get, is
100.
it 100?
100.
Okay. Milligrams. That would be the new dose, isn't it? Thank you so much. Okay. So go to part C. Okay. A patient originally weighs, okay, so the weight of the patient is 82.6 kg, okay, and this patient loses 15% of the body weight, okay. So what would be their final weight? Okay, so we are looking for the new weight that they're going to have if they lose 15% of this weight. So we still go back to getting the 15% of 82.6, isn't it?
Mm.
So what would be 18? What would be 15% of that?
It's 12.39.
12.39, isn't it?
Yeah.
Kg. Okay. So now we want to make sure that we know the final weight. So we've lost 12.39 kg, isn't it? That's a 15% that
Yes.
we've lost, right? So we are going to subtract there so that we know the final weight. Okay. So now I want this final. I want someone to give me the final answer. Applying the rules of significant figures that we've done so far. I want someone to give me the final answer there.
It's
70.2.
70.21.
Okay. So there's someone who's saying 70.21. Okay. Others
70.2.
70.2. Okay. Yeah. So this is what I wanted. So whenever you're doing calculations, so now this is tertiary education. You need to apply whatever principle you are learning, isn't it? So you'll be given such a question and you look at it, you think it's a simple question, then you get your paper, you answer it, then you get your paper, then you find that you are marked wrong because you are not applying the principles that you are learning. So it's very important to be cautious applying the principles that you are learning every day, isn't it? So whatever we've done is a foundation. So get it, be using them. even as we are going to the next session, which is your chemistry, right? So we'll be doing a lot of calculations there. Make sure you carry these principles with them there so that you'll be applying them. Okay. So in this case, we are subtracting numbers here, right? So it means that
Yes.
the final answer should have the least decimal point, which is 1,
Oh,
isn't it?
one.
Yeah. So we get
70.2.
70.2 kg. Good. Okay. Let's move. Let's go to the next one. An infant birth is 3.18 kg. Okay. So that's the weight at birth, isn't it? Okay. Her discharge weight is 2.78 kg. Okay, so after being discharged, this is the weight that this infant is having. Okay, so what percentage of her body weight did she lose? Okay, so we want to know what percentage of the body weight did this patient lose. Okay, so what are we going to do in this case?
We subtract.
So the first thing that you want to know is to know the weight difference, isn't it? Okay, so
Yes.
we're going to get 3.18 minus 2.78, isn't it? So what is the
Yes.
weight difference there?
0.4.
0.4.
Okay, 0.40 kg, right? So this is the weight difference, isn't it? So now, the next thing that you want this weight difference to be in percentage because they're saying what percent, isn't it? Okay, so
Yes.
it's more like you're
Yes.
having a decimal number and you're converting it to percentage, isn't it? And what we know is that the weight that this infant had at birth is this one, isn't it? So this is the
Yes.
weight that you have it, and you are losing this weight. Okay, so it means that at first, the weight that you are using is 0.40 kg out of the 3.18
3.18
kg that
times
this is
100.
that, isn't it? So we multiply
Yes.
by, so
100.
now 100, isn't it? We're converting this to percentage, isn't it? So multiply by 100. The kg and the kg will go, means that we're going to remain percentage as a unit. So what are we getting there as the final answer? The correct number of significant figures.
12.6. 12.6.
0.
12.6.
12.6.
4.6, isn't it?
6.
Percent. Okay, thank you so much. That's what we have in there. Okay, so that's it for this tutorial sheet. I hope people are clear with whatever we are having in this tutorial sheet. Okay, so we're going to wait for the next one.
Sorry, say.
Yes, there's a question.
Since we were doing division, isn't it supposed to be 13%?
Okay.
Like the
So now,
significant figures.
okay. So now, yeah, the thing is, at the last stage we are dividing, right? Now there's
Yes.
also the first stage we subtracted, right? Now when you have such a situation, always defer to the question that you've been given. Okay, check the question. How many significant figures are you having in that question? So in this case, in the question, if you check the question, they are giving us 3 significant figures, isn't it?
Yeah.
So
Okay.
you want to maintain that uh, uh, uh,
3
scenario
significant figures.
having 3 significant figures, isn't it? So that's why I've accepted 3 significant figures, because you notice at first we subtracted and then we went on and divided, isn't it? So it would be very unfair for us to just consider the division part without also considering the subtraction parts. That's why I will also consider what have been given in the question, which are three significant figures. I hope that answers the question.
Okay.
Yeah. So in this case, three significant figures will be accepted. Okay. But you are right. If we are following the last step, which is dividing, we are supposed to have two significant figures because this one is having two significant figures, then this is three significant figures. But we've also subtracted at first. So it would be very unfair for us to just consider the division part, isn't it?
Yes.
Yeah. So we go back to the question, to the first, to what we've been given in the question. Okay. Yeah. So I think that's it for this story sheet. So I was saying, uh, as we are waiting for your next story sheet, I think it is on stereochemistry. So you can just, I'll upload this as well on the website. There are some questions that we haven't solved. Try to attempt them, especially here. Okay, I think we didn't solve some questions here. So just
Then
attempt them. If you're having any challenges, feel free to inbox me. The same line I've used to send it in. That's a line you should be using whenever you're having anything concerning chemistry. Okay, so I'll be with you guys the whole semester. Okay, yeah, so I'm going to upload this class on YouTube. Also, there are also tutorial videos on stereochemistry and other tutorials for last semester. So you can do well if you have enough time. You can go and check out the tutorial sheet for stereochemistry for last semester so that you are getting familiar, even as you are learning stereochemistry, you should be able to get familiar with the things that you expect, isn't it? Okay.
Okay.
So just go on the
Yes.
website. Let me just show you where you can find them, including whatever. So I'm going to create a folder for this semester. But for if you want to have access for previous semester and other semesters, actually, all our classes are recorded. Okay, so let me just show you. Let me just share my screen. I show you. There's a hand. Someone has a question.
Yeah, which subject is this?
Okay,
Is
so you
this
can
maths
ask.
or chemistry? Oh, okay.
Chemistry. This is
Okay,
chemistry.
thank you.
We are solving the
Thank you.
tutorial sheet. We are solving the tutorial sheet. Yeah. So are you able to see what's on my screen here?
Yes.
Yeah. So once you subscribe, you should be able to get. I hope people know how to subscribe by now. Okay. So you should be
Yeah.
able to access the folder for chemistry. So once you enter in that folder for chemistry, let me just wait for it to load. So you're going to see these folders here. So you go in the one written general chemistry. Okay. So you open. Okay, so there are these folders. Okay, so there's topic lessons. So if you want to learn more on this topic that we've done, there are recorded classes on this topic that we've done, measurement, units and measurement. Okay, so you find recorded videos for each and every topics that you're about to learn. So even before you go for class, you know that you're learning your chemistry. You can just come here, you go in this folder written topic lesson, you enter in the folder. Okay, so let me wait for it to load. Then you are going to see where it's giving you different topics here. Okay, so if you enter in the folder for units and measurements, you're going to see videos on units and measurements, atomic molecules. All the topics that you're going to cover are recorded in the website, so you can find time to go there, right?
All
Also,
right.
also so that was a folder for topic lessons. So also summarized notes, you can find them there. For tutorial sheets and assessment, so you can go in that folder. I'm going to make a new folder for this semester. So you choose your university, UNLAS, okay? Okay, so you choose also your semester. So let me just wait for it to load. You choose your semester. If you're in second semester, you go in the folder for second semester. First semester, go in first semester there. Okay. There's someone in the question you can ask.
So I wanted to ask if we only access these folders when we pay.
Yeah, when you subscribe, that's when you can access these folders. Okay.
Okay.
Yeah. But for now, we are doing free classes. So after we are done with free classes, even these
Yeah.
classes will be using this website to access them. But for now, yeah. So there's a
Say
question. There's another one.
how much is subscription?
So for now, there's a promotion. We are doing at 100 quarter for now. So you can use that promotion to subscribe. Okay. So now these are the folders for the other semesters that we had. So for last semester, you can see this is July 2026 intake. Okay. Okay. January, sorry. So for January, you can see the tutorial sheet, all the tutorial sheet which these guys had. They are there. The solutions are there, starting from the first one, which is units and measurements. Stereochemistry, the videos for stereochemistry are already there. Kinetic molecular theory, atomic structure. So you should be able to access these uh, video solutions on the website. So you just go there, okay? So that's what we have. Also, the past papers, okay? So at some point, you also need to go through past papers so that you are familiar with how questions are going to be asked in a test or an exam, okay? So let me just check the folder. So there's also a folder written quizzes, past papers, and exam. Okay, so that folder, you notice that I think we've solved questions from 2025 down to 2022 somewhere there. Okay, so we also have a session with you for this for last semester so that we also solve the